Yeah? Okay. Now we're going to invite our next speaker. It is an insight session. So we're going to talk about the new oil. What is the world's most valuable resource? Okay? And please join me in welcoming data scientist, associate professor, analytics, information and operations department at AIM, Dr. Erika Legara.
Good morning, everyone. Good morning. I wasn't expecting around 80% to 90% audience, so I'm very happy. I was actually joking Dinah yesterday, and I said, I'm probably going to be just speaking to the organizers at 9 a.m. But I'm very happy that you're all here today. Can we pull up the slides? All right. Today we're going to talk about data. All right, so they're saying that data is the new oil. Let's see later if you're convinced that indeed it is. Yesterday, during one of the panel discussions, I think that was with Chris, Aisha, and Arthur, together with David, they talked about the future of cities, right? You remember? Yes, and there are talks about smart cities, and with us right now, we have our own smartphones. You've heard of smart cars. When I gave this talk in a DOST gathering, one of the students asked about smart farming. Right? So smart. Why do you think so? Why? Why are they using the term smart there? Because the computer is smart. Essentially, it's because, lately we've been producing so much data. And this has informed us and allowed us to understand the world around us better. Aside from data, we're now able to store. Okay, usually I would have a quiz. You remember this? Diskettes? It tells me your age, actually. Alright, if I have enough time, I would quiz you, maybe one quiz. The very first one. Which year do you think this was released? I hear 80s. Who says 80s? Alright. 70s? No? Really? How about 1960s? How about the rest? Why aren't you answering? Are you up? Again. 1960s. I need to see hands. Alright, there's a few. 1970s. Okay. More. 1980s. Really? Okay, actually it's 1960s. Alright? And then we had the 5 1/4 that came out in 1976. And then in 1981, this one. The different sizes, 80 kilobytes. It's about the extraction and cleaning of data. And once you have this data, it's about looking for patterns and then building predictive models. When you build predictive models, that's where the difficult part comes in. Because there's a lot of science, math, statistics, computer science involved in the process. However, if you are a decision maker, you know that it doesn't matter how complex the models or how accurate the models that your data scientists can produce, right? Unless they tell you specifically what you should do. So it's equally important, which a lot of people forget, the insights. They call it the soft skills, the soft part of data science. Many people forget about this, right? But if you ask a C-level exec, I actually talked to one a few months ago. He really complained because he said that, I paid these junior data scientists. Yes, they're good at neural networks. They're very good at artificial intelligence, machine learning. Gave them all the data, did a lot of crunching. But then at the end of the day, the data scientists gave him different charts, different graphs, and he just said, so what? Right? All those efforts to nothing. Because we need data scientists who can crunch data and who can also produce actionable insights and communicate these insights so that decision makers can make data-driven decisions. You agree? Yes. Alright, so data science is really a tool. The most favorite part of data science, my most favorite part about the field is that it cuts across sectors. It cuts across industries. So when I, for example, work with the bank, when I work with the manufacturing industry, when we work with governments, we really learn a lot, right? As long as your sector has data that can be analyzed to produce valuable insights, to produce business value, then data science would be very useful. It can help improve efficiency, improve services, maximize profit, minimize costs, etc., etc. So you saw all the capabilities needed to become a data scientist. You know that data science cuts across industries. This is why we shouldn't be surprised when Harvard coined data scientist as the sexiest job in the 21st century, right? And until now, we data scientists are still in demand, right? And it's just going up. All right. Some examples. So some of you are like, what is data science? Spam filter is data science, your emails. Other examples from the industry. So this is a favorite example of mine. This is from the UK, Auto Parts Alliance. What they did was they hired data scientists to look through 20 million transactions. That will not fit in an Excel sheet, right? Or will it? No? I haven't used Excel for a while. Sorry, Microsoft, if you're here. So it will not fit. So you have to do analytics on 20 million transactions. When they did this, the data scientists were able to find, specifically, they were able to identify certain products to sell at a discount at a given time. By identifying the correct products, they were able to boost revenue by 6 million British pounds. That is impressive, right? Another example is this oil company. They used AI and machine learning to perform preventive maintenance, right? If you can predict when a specific item in your system would break down, then you can already buy replacement parts before it breaks down. Because when a valve, for example, breaks down in a factory, it could hamper the entire process, right? So machine learning and AI is very useful. The next example I'm going to show you is something that we actually did. When I say we, Chris and I and our team back in Singapore, but this was with the Manila Water Company. So what they asked us to do here is to help them predict the water level of Angat Dam, right? They can already predict it, but they wanted us to make a much earlier prediction. So we used neural networks and AI, and in the end, we were able to extend the time forecast from 2 weeks to 6 months. What can you do with 6 months? There's a lot that you can do, right? So that's actionable insight for you. Another example is this work that we did for the Singaporean transport system. This is with a government agency, where we built a data-driven simulation tool to explore what-if scenarios. Like, what if the train breaks down? What if we have more commuters using the MRT system? Will it be able to handle it? So at the end of the day, after 2 years, we were able to produce this, a platform. Okay? The big dots there are the MRT stations, the small dots, the bus stops, and the color, it tells you how long it takes to get from one point, one region, to another. Now, if you're a policymaker and you have a bird's eye view of all these things, then you can immediately tell which parts of the region lack service, right? Like, for example, the red one over there. So you can maybe add more infrastructure or add more bus service, right? Other scenarios that you can look at is, what if there's a breakdown? What will happen, right? And this is where this simulation comes in. It's like a sim city. You're like reconstructing what's happening in the real world using data. Alright? So the data that we use here is actually just the tap in, tap out. You know the beep card? In the Philippines, we have the beep card, yes? Yes. So that's what we use there. And when you click on a station, it's like there's different sizes. It tells you how many people are inside the trains, outside the trains, on the platforms, and you have all the statistics on your right side, the number of commuters in a station, the waiting time of individuals. You see, if you can measure it, then you can improve it, right? You don't just use intuition when you study these kinds of things. Now, the next one here is, we actually disrupted Clementi. We said, what if there's a disruption? What will happen? How will it affect the entire system? You know, you see that not just the adjacent one, even the non-adjacent stations are affected. So if you want to deploy shuttle buses, you know which specific stations to target. And it's data-driven, right? So that's an example. Other things that we explored, this was actually published. We looked at how the train system will behave if we increase the commuter population. How the system will behave if we put some congestion-reducing strategies, like say, instead of traveling from 8 a.m. to 9 a.m., if you travel from 5 a.m. to 6 a.m., you get a free ride, stuff like that. We get to actually test it in a data-driven model. I think the very message that I want to leave with all of you here today is that we have so much data. A lot of people are calling data as the new oil. We have to use these data, right? Implementing policies in this day and age without data, you know, it can be very expensive, time-consuming, and if wrong, can be very catastrophic. Yes? And I'm just going to feature Chris here. So, he says that data-driven operations are the new normal. And not just him. There was this study from the MIT Sloan Management Review. They interviewed over 3,000 executives. And what does this slide show here? 63% of those interviewed believe that the impact of AI on their offerings will be large. Right? And here, 59% of the executives believe that in 5 years' time, beginning 2017, AI will have a large impact on their processes. So we all better get on board, right? However, I know that there's a lot of you here who are already aware of, or data aware, or AI aware, but there are challenges. Where are we going to find the data scientists, right? I'm sure it's not just the Philippines. All other countries in Asia and probably the world, we look for data scientists. Ever since we got back here, we've had chats with various industries, even the government. They're all looking for data science, for people who are good with data. And not just that, there's a lot of problems that they're looking at actually. Lack of understanding. They want someone to teach them what data science is. They want to know, what is AI, right? So that they really understand what this is all about, so they can really assess if this is something that they need. It is important that we really collaborate with each other. No, seriously. So this is not just an idea, this has to be done. Right? Academia working with industries and governments. Do you agree? Yes. And this is why I'm really, really proud. The reason I came here really was because I so much believe in this, was to be part of this. So I joined AIM together with Chris last year, and we launched, thanks to Jikyal, our president and team, the very first data science formal program in the Philippines. Yeah? So this program is rigorous in nature. It's in the business school, but it's rigorous. So we made sure that all the data science aspects are there, the technical. However, we also made sure that the soft side, general business and management courses are there. We want to build holistic data scientists. All right? And these data scientists, the field is practitioner-oriented. We have to make sure that their capstone projects are reflective of the real world. So we are partnering with various companies, local and international companies, to give our students research problems to solve while in the program. To support this, we also built a research lab right? This is what we call the Analytics, Computing, and Complex Systems Laboratory. Because what we realized was that a lot of SMEs, those who cannot afford data science, want to go into data science, but they don't have the resources. We offer this resource to them, right? This is why we want to really work closely with the government to help us in this initiative. We have a lot of data scientists. Wow, they were so happy with that. And then we had the 1.4 MB. I felt so cool when I was like using 1.4 MB. And then yesterday, I was given this thumb drive, 64 gigabytes. Wow, right? That's like 45,000 times as the last one there. So that's data storage for you. Aside from data storage, we also have the computing power, right? In fact, if you're gonna add all the data in all of the world, 90% of them were just created in the last 2 to 3 years. So imagine that kind of information that we have right now, right? I spoke about computing power. Did you know that the first computers were actually the women in NASA? Did you know that?
Yes.
Yes, so proud to be a woman. Yeah. And then there was the IBM computer. The IBM computer cost $6 million US. It was so huge you could fit a bus in that computer room, right? And it can execute 5,000 operations per second. So operation is like plus, minus, divide, times, 5,000 in 1 second. Fast forward to today. You have computers with you, right? Your smartphones. It can execute 25 billion instructions per second. So can you just imagine what are the things that you can compute, that you can analyze with this amount of power? Now let's go back to data. I was looking at the internet, and this is what I saw. You can actually visit a site called Internet Live Stats in 1 second. Every second. So let's try this. You breathe in, inhale, exhale. Good. 1 second. We just produced 2.6 million emails. The world produced that much. And I got this data back in November 2017. And yesterday, actually, early this morning, I checked the new stats. From 50 gigabytes of internet traffic to 55,000 gigabytes. So that's 5 terabytes of increase of data in 1 second. Impressive, right? So this is just internet data. We also have business data. I got this from the internet. This is from a credit card company in Barcelona, Spain. So they're tracking all the credit card transactions. Every time you swipe your card is recorded. How much you spent, where you spent it, how often you use it. Right? So this is data for you. Another set of data. Air traffic in the UK. If you have this kind of data, I bet 20 years ago we didn't have this, right? You agree? Yes? We didn't have this 20 years ago. 10 years ago maybe, but not this kind of visualization. Now if you have this information, you will think, yes, we can improve air traffic control. That's obvious. But another thing, if you're imaginative enough, there was actually a team in Europe that used this information to predict where the next epidemic would occur. The spread of disease, right? This was the prediction of H1N1. So you see, if you have information about the susceptibility of people, the virus, how they travel, you can actually make this kind of analysis. This is a data-driven model. All right, going back to data. Who here has Facebook? That's good. Gmail. Wow, more. May I know how much you're paying, Dinah, for this service? It's free? Yeah? How about the guys over here? How much are you paying for the service? Nothing, right? We pay nothing and we upload so much photos. But are we really paying nothing? How much are we paying? You're paying them with their information, your data. They know you. They sell you your information. That's how much you're paying them. This is why the economists coin data as the new oil. It's the world's most valuable resource, right? That's why there's a lot of controversy now on Facebook. I'm not going to go there, but I'm pretty sure you're all updated about that. However, when we talk about data, when people, especially those in the C-level, individual, supervisory, when they hear about data science, they get all excited, hyped up, and all they think about is data. And whenever we give a talk, we always remind people that big data analytics and data science is not just about data. You know this guy? Yeah, you're all geeks here, you have to admit it. Alright, so it's not just about data, it's about the science, it's about getting value from data. So here, I just define very briefly what data science is. There's a lot